Hello everyone, I am Dr. Rajesh. I welcome you in this video lecture, and in this video lecture we will do the successive differentiation of the functions of the type which contains the product of exponential and trigonometric functions of this form, like e a raised to the power x into sine bx plus c, that is e raised to power ax sine bx plus c. So what it will be? It will be a square b square raised to the power n by 2 e raised to the power ax as such, and this will be same plus n times tan inverse coefficient of x in sine bx plus c. Coefficient of x is b divided by coefficient of x in exponential e raised to the power ax. Similarly for cos, here will be cos. So now we will be making use of these two formulae to solve the nth order differentiation of such functions. So one of such function I am going to write is e raised to the power x sin x, and say this is y. So I am going to directly write yn based upon this formula. What is that? Coefficient of x is 1 and here x is also 1. So it will be coefficient of x here is 1. So 1 square plus coefficient of x here is 1 square raised to the power n by 2. Fine. e raised to the power ax, eax as such. So here e raised to the power x will be as such, sine argument bx plus c as such, argument here is x as such, plus n times tan inverse coefficient of x in sine, it will be 1 divided by coefficient of x in e raised to the power x, it is 1. So this will be 2, 1 square plus 1 square is 1 plus 1, which is 2 raised to the power n by 2 e raised to the power x sine x plus n, tan inverse 1 is pi by 4. So this is your yn. This is the nth order derivative of y is equal to e raised to the power x sine x. Now if we are given that find nth order derivative of e raised to the power x cos x sin x. So how will you do it? Because we don't know the nth order derivative of the function containing product of two trigonometric function and one is exponential function. If instead of this cos x sin x there would have been e raised to the power x and cos x only, then we could have easily written by this formula, and instead we will be having e raised to the power x into sin x only, then we could solve it by this formula. But now here one trigonometric function is more, so we have to we need to reduce. But can we write it something like 2, this will be 2 sin x cos x. So can we write it like that? Yes, we can write it like that. What it will be? It will be nothing but it's sine 2x. Fine. So we will be seeing what happens next. This will be e raised to the power x sine 2x. Now I am going to write its nth order derivative. So let's write the nth order derivative yn. What is the coefficient of x? That is 1. Coefficient of x here is 2. So now let me write the nth order derivative, which will be 1 square plus it will be 2 square raised to the power n by 2 e raised to the power x into sine 2x plus n times tan inverse coefficient of x in sine, that is 2, divided by coefficient of x in exponential, that is 1. So this will be 1 by 2 5 raised to the power n by 2 e raised to the power x sine 2x plus n tan inverse 2. So this will be the nth order derivative in this particular case. So if we are given that find nth order derivative of e raised to the power x sine cube x. So how will you do it? Because we don't know formula when a sine cube x is given, but we know that sine 3x is equal to 3 sine x minus 4 sine cube x. From here we can calculate the value of sine 4 cube x. This will go over here and this will go over there. This will be 4 sine cube x is equal to 3 sine x minus sine 3x. So this implies that this is further equal to e raised to the power x 3 sine x minus sine 3x divided by 4. So this will be 3 by 4 e raised to the power x sine x minus 1 by 4 e raised to the power x sine 3x. So if we have to write its nth order derivative, so here I could write it will be y n is equal to coefficient of x is 1, here is 1, so it will be 3 by 4 1 square plus 1 square will be 2 raised to the power n by 2 e raised to power x sine x plus n times tan inverse 1. This is minus 1 by 4 1 square coefficient of x here is 3, 1 square plus 3 square is 9 plus 1 is 10 raised to the power n by 2 e raised to the power x as such sine 3x plus n times tan inverse 3 by 1. This is further equal to 3 by 4 2 raised to the power n by 2 e raised to the power x sine x plus n pi by 4 minus 1 by 4 10 raised to the power n by 2 e raised to the power x sine 3x plus n times tan inverse 3. So this will be nth order derivative of the function y is equal to e raised to the power x sine cube x. So similarly we can also calculate y is equal to e raised to power x cos cube x. In this case you will write the formula for cos 3x, what it is 4 cos cube x minus 3 cos x. From here you can calculate cos cube x, put it over here, and on the same line you can calculate this result also. Now we will take up some more problems based upon these two formulae, and the problem is given by, so this is the next problem, that find the nth order derivative of a raised to the power x sin x, where a is a constant quantity. So how will do, because we know the formula, if there would have been e raised to power x, but here is actually a raised to power x, so we are not in a position to use either of the formula over here. So what will we be doing? Can we write it something like e raised to the power log a raised to power x? So can we write it something like, yes we can write, and it is log to the base e. So this will one way it will cancel out, and we will be left with a raised to power x. This is a sin x. So this will come before log by property of log m raised to power n is equal to n log m. So this will be e, it will be x log a to the base e, fine, and it will be sin x. So this will be e x log a is assumed as a dash, where a dash is a constant quantity. Mention where a dash is a constant quantity having value log a to the base e raised to the power a dash x sin x. Fine. So now we'll be finding its nth order derivative, that is yn. What it will be? Coefficient of x is a dash, coefficient of x is here 1. So a dash square plus 1 raised to the power n by 2. It's 1 square. 1 square is obviously 1. E a dash x as such sin x plus n times tan inverse 1 by a dash. Fine. So I am going to substitute back the value of a dash is log a, I want to write to the base whole square plus 1 raised to the power n by 2. Fine. E log a to the base e into x. Fine. This will be sin x plus n tan inverse 1 by log a to the base e. Fine. This is further equal to log a to the base e square plus 1 raised to the power n by 2, and this will go up over there e log a, this x will go over here in by property of log, and this will be exponential is inverse logarithmic function, so this will cancel out. Sin x plus n tan inverse 1 by log a to the base e. So this will be 1 plus log a square and raised to the power n by 2. This will be a raised to the power x sin x plus n tan inverse 1 by log a to the base e. Fine. So this is the required nth order derivative of a raised to power x sin x. So this is important question from examination point of view. Now we will take up the another problem. This is the second problem. Here we have to find its nth order derivative. Can we write it as 1 plus cos 2x by 2 sin x? Fine. Can we further, it will be 1 by 2 e raised to the power ax, it will be sin x, and here will be 1 by 2 e raised to the power ax cos 2x sin x. Here you see we are in a position to use this formula, but here we are still having a product of two trigonometric functions. We can make it 1 by multiplying here by 2 and here by 2. It will be 1 by 2 e raised to the power ax sin x plus 1 by 4 e raised to the power x and this will be sine 2x plus x is 3x minus sine a minus b, that will be sine x. So this will be 1 by 2 e raised to the power ax sine x plus 1 by 4 e raised to the power ax sine 3x minus 1 by 4 e raised to the power ax sine x. Now you see we are going to collect this and this term, so it will be plus 1 by 4. So can I write it as 1 by 4? First I am going to write this one, e raised to the power ax sine 3x plus 1 by 4 e raised to the power ax sine x. Now we will write its nth order derivative 1 by 4 as such. Coefficient of x here is a, this will be a square plus coefficient of x is 3, that will be 9, 3 square will be 9, n by 2 e raised to the power ax as such sine 3x as such plus n times tan inverse 3 by a, fine, plus 1 by 4 a square plus 1 square is 1, n by 2 e raised to the power ax as such sine x plus n times tan inverse coefficient of x is 1, 1 by a, fine. So this will be the nth order derivative of the given function. So in this lecture we have studied how to find nth order derivatives of the term of the form e raised to power ax sin bx plus c or e raised to power ax cos bx plus c, and in case we are given exponential and product of two or more trigonometric function, then we try to reduce it into functions, that is write it as a sum of functions containing a product of exponential and trigonometric only, like we did in this particular case. Look over here, we reduced it to the functions that contain product of exponential and trigonometric as a sum of functions. Okay, so that way it can be done easily. So that's all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.